you got to tell me what are the different functionalities. Okay, you can write it in the chat box and then I will list them down here on my screen. Okay. Let me do one thing. I'll make use of a notepad. Okay. Okay, I have some functionalities here. My account. Okay. Verify the bill. Fine. Support. Okay. And then my account. Okay. Wireless. Okay. Support. Then shop. Right. Register. Okay. And then wireless. All right. Then learn more. Fine. Okay. What else? Yeah, finding a store. This I said you. Wireless. This is it. There are so many functionalities, you know. Your bill payment. Right? Okay, fine. So these are, you know, the different functionalities that you can see on the application. Okay. Fine. So these are the different functionalities that you can see in the application. All right. Now, these were developed by whom? By the developers. Who wrote the programs for all these? This was written by the developer. Now tell me, can a single developer write all these programs? Is it possible to, you know, develop such a huge website by a single developer? No, it is not possible, right? So we'll be having a team of developers who are going to develop this software for us, right? So let's see how they do the development. Okay. Let's say this find store, login and personal, it is done by one developer. Shopping about TNT and verify bill, another developer. Support, shop and register by another developer. Wireless, learn more and then bill payment by another developer. Okay. So let's say that there are about how many developers? 4 developers in our team. Okay. So a development team with 4 developers has developed this entire website. So how they develop? Do they work on a same computer? Because they have to prepare one software, right? So are they going to, you know, attack on only one computer and everybody will start programming in the same one? No, it doesn't happen like that. So everybody will be given their, you know, a different systems. Each developer will be assigned with a different computer on which they will be developing the programs for the functionalities which are assigned to them. Okay, so they distribute the work among themselves. Each developer will be writing the programs for few functionalities. Okay, and then later what they do, after they have developed the functionalities assigned to them, they integrate all those functionalities and then they form one software. Okay, so these are nothing but units of the code. So each developer is going to develop some components or units of the code. Okay, and then they go for the integration. But before integration, they have to test it. Okay, So before the integration of these components or the units of programs, they are supposed to test it and then only integrate. Alright. And then after integration, again the testing is done to check whether they have been integrated properly or not. I can give another example. Take an example of a car manufacturing industry. What happens there? All the different components of the car are prepared first. I mean, they are manufactured first, right? The different components of the car, they are manufactured first. Then later, they are tested. Each and every component has to be tested, okay? A defective component cannot be considered for the assembling or the integration. So all the components are manufactured and tested. Then later they are assembled into a car, right? And again we have to test whether they have been assembled in a good way or not, properly or not, right? This is how a car is manufactured. Similarly, when a software is being developed, the different components or the units of code have to be developed by different developers, and then they have to be tested and then integrated, again tested if they are integrated properly. Okay. So this is nothing but it is called as the unit testing. What is this called? It is called as the integration testing. Clear, everybody? So unit testing means what? Testing the individual components of the code is called as unit testing. Integration testing means testing the integrated software. Okay. But here you observe, can a QA do this kind of testing? Because the testing is being done here on what? On the components of the code. The programs are being tested here. So can the tester do it? Do you know the programming to do the testing on this? We do not know. Neither me nor you. We do not know this. So who has to do the testing here? Developers will do the testing. Okay, don't be surprised. Yes, developers are going to do the testing because it is the testing on the program. Okay. Here also, developer does the testing, because the testing is on the programs, set of programs that are integrated here, right? So developer does the testing here. After the developer does the testing on the integrated software, so we get a ready-made software now. Like, you can see here, AT&T. Okay, this kind of software is ready now, which we can see it. So we got to test here, and this kind of testing is done by the testers. Now let's say I click here my AT&T, then I click the bill payments. So the page for doing a bill payment will appear. I have a question for everybody. Did anybody see any kind of program that got executed? Did you see any program that got executed here? Yes, anybody? Yes or not? Did you see any program that got executed? Okay, you got to answer me. Rishali, Sridevi, Shilpa, Sarita, Renu, Lakshmi, Jayanti, Febi, Dhruvita. Did you see the program? Which program got executed? No. We did not see any program. Okay, I just clicked on this bill payment. Some page opened. What program did the developer write? I did not see any program. I did not see any code over here, right? So what does that mean? We got to test on the application which is ready-made. We cannot see the programs as a tester. The users also cannot see what programs have been written in the backend. Okay, only developers know which components got executed. Okay, what programs got executed, only they know it. We do not know it. Okay, let's say we have this car. Now the car is assembled, it is ready. Okay, and We have our car ready. So when we want to, do a test drive on it, can you see the components that are present within it? As a user or as a tester, do you open all the components again and test how it happens, how it works? No. We test whether all the, like the visible components like your steering and then let's say your windows are working correctly or not. Okay, your brake when we apply it is working properly or not. The accelerator works correctly or not. You just check that. Okay, nobody opens up the entire car and tests it again, right? So this kind of testing is nothing but we call it as a system testing. Means testing the end application wherein we cannot see the programs. As a tester, what I do, I click on the different links, I check whether they are working or not. I try to enter different user ID and password, click on the login button, I check whether it is able to log in or not, right? This is how I do the testing as a tester because I do not know programming. Okay. So system testing is done by whom? It is done by the QA. And after the testing is done by a QA, we release it to the client and the client also does the testing. Now let's say you want to purchase a laptop. Do you purchase it just like that blindly? No. First you try it out, right? And then you purchase it. Let's say you want to purchase a car. First you take a test drive on it and then you make a purchase, right? So as a user, even you are going to do the testing. It is called as acceptance testing. User acceptance testing. Okay. Who does this? User does this. Or also, in short, we call it as a UAT. So users are going to do the testing in order to decide whether to accept the software or not. Okay. And there are two kinds of testing here in the user acceptance testing. Alpha testing, beta testing. Alpha testing means the users go to the developer's site and they do the testing. It is called the alpha testing. Beta testing means the users test in their own environment or the real-time environment, or we also call it as a production environment. Okay. So this is alpha testing in the developer site. In the production environment, the users do the testing. It is called as the beta testing. I will give another example here. Okay. Let's say we have the software that we have developed for Bank of America. Not the internet banking system, but this software is being used by the employees of the bank. Okay. So we have Bank of America and we have developed some software for their employees. Means for, let's say the customer visits a bank and then the employees will take their account number, they will enter it and they will help the customers every day for, let's say the bill payment or the funds transfer, account summary. So the employees are going to help the customers who visit the bank, right? And how they help? They just enter the name of the customer or account ID of the customer and then they get all the details. They help the customer. So they need a software, okay, which are to be installed on the computers of the Bank of America. But where is that software developed? In our IT company. Let's say IBM is our IT company wherein these softwares are developed, right? So this is nothing but it is a development environment or it is called as the developer's site, right? And Bank of America computers are what? These are basically the production environment. Okay. So if the user is testing here in IBM, they are visiting here. I mean the employees are visiting to IBM and doing the testing here. We call it as what? Alpha testing. If the users, I mean the bank employees, they are testing on their own computers in the production environment, We call it as a beta testing. Okay, clear everybody? Any questions that you have? Anybody any questions? Okay. Fine. So we have unit testing, integration, system acceptance testing. Unit and integration are done by the developers because the program is involved here. System testing by QA and user acceptance testing by users. Okay, one more concept I will add here. Since the program is involved here and the developers are doing the testing, this kind of testing is called as white box testing. Okay, what is it called as? White box testing, because the program is visible here. The testing is done on the programs here. That is the reason we call it as the white box testing. But just observe here, system testing, we do it on the end application where the program is not visible. What kind of code is being written, it's not visible. User acceptance testing also same. We do not see any code components here, right? So this kind of testing, we term it as a black box testing. Okay? Clear everybody? Fine. So let's go back to our PPT. So what do you see here? We have one side the verification, another side the validation. Okay. Validation means at the module design, means at the different units of the code, you do the unit testing. Once all those units are connected together, it is nothing but the architecture. So we refer the architecture design in order to do the integration testing. Specifications means during the analysis process, the specifications are prepared by the business analyst. So we refer those documents in order to do the system testing. Then we have the requirements which we had collected from the client. The users do the acceptance testing based on those requirements. Okay. And this part, the testing part is called as validation, and this design part we call it as the verification. Why do we have different names here? Okay. Validation means it is quality assurance process. Okay. What is validation? It is the quality assurance. Okay, I'm writing it here. This is the quality assurance process. Okay. This is the quality control process. Why is this difference? Control here, assurance here. Assurance means what? We just got to decide whether the functionality is working or not working. Means whether it is fail or whether it is pass. Pass means what? It is working correctly. Fail means it is not working properly. That's it. We do not do any, modification or a repair here. Let's say your car is there. Some component is not working. Let's say the steering is not working properly. We just say, okay, steering is not working properly. We do not open up and then we try to find out what is the reason for it and, make some correction there. No, we just tell this is not working. If the brake is working, we just say, yes, it is working. That's it. That is called as what? Quality assurance. Okay, validation. Quality control means, let's say the developer sees that the steering is not working. So he is going to make the correction there. He is going to take the corrective action. He will find out why it is not working and then he will make it work. So here corrective action is to be taken. Okay. He not only just finds out what is the problem, but he also takes a corrective action in order to correct it. Similarly, in the development process, whenever there is some error, it has to be corrected. The defect is corrected here, but here we only decide whether it is pass or fail. Okay, so that is quality assurance. Clear everybody? Okay. If you have any doubts in this V model, Please let me know. And this is not much different from your waterfall model. The only thing is we are doing the testing here at the different levels so that we can avoid the defects. But otherwise, this is also a sequential design process. In case there are change in the requirements, we cannot consider them in the mid of project. All the remaining features and the drawbacks remain the same. But we are paying some more importance here on the testing process. That's it. Okay. Anybody any doubts here? Questions? Everybody feeling sleepy because this is weekend? Okay, if you are sleepy, tell me, then I will give you some assignment. Okay. Yeah. Okay, you got to answer me. Okay. Otherwise, if I feel sleepy, then the entire class will sleep here. Right? So you got to keep me awake by answering to my questions. Fine. Okay. The next model. It is called as what? Spiral model. One second. Where am I receiving these messages? Okay. Oh, okay. I think it was not sorted properly. Fine. Can you tell me the pin number? I'm in listen mode only. Sarita. Okay. No, Sarita. You are not in the listen mode. Okay. You are on mute. In case you have any questions, Sarita, let me know. I will unmute you. Okay. Then. V model, does requirement gathered are checked with the users? Yes, Lakshmi. You take any model, whenever the requirements are gathered, we got to, first cross check with them, take the approval and then only proceed. Okay. Then, fine. Okay. Next model is the spiral model. Now the name itself suggests, okay, that this is spiral in nature. Can you see? Spiral model means obviously, right? It should be spiral in nature. You cannot expect anything like a square over here, right? It is spiral in nature. And the important feature of the spiral model is there are 4 important phases: the planning, risk analysis, engineering, and then the evaluation. Okay. So what are the 4 important phases here? Planning, risk analysis, engineering, and evaluation. So you might be wondering, where have all the different phases that we learned till now, where did they go? Right? You might be thinking that. No problem, I'll tell you. So engineering includes all your design, your development process, everything is included here itself in the engineering. Evaluation is nothing but your testing process. Okay. So the phases do not change. They are going to be the same. But we have, classified. Then we have the planning. Risk analysis is the additional phase that we have added here. Okay. And here we give more emphasis on this risk analysis. Let's see what is this risk analysis. So in the spiral model, what happens is you get the requirements. Okay, you do the planning. And then you do the risk analysis. Right? And after doing the risk analysis, only you do the implementation. Okay. That is like, design, development, everything here. And then you are going to evaluate it, means test it once. And then again take a new set of requirements, again do the planning, risk analysis. So this is going to continue as a spiral. Okay. What exactly happens here in the risk analysis? We are not going to get all the requirements at one shot. Okay, let's say now Dhruvita wants to construct the house, but she has not still decided on certain things. She says that she wants the 4 bedrooms. Okay, that's fine. She wants a parking place. She wants a lawn. All that is fine. But she hasn't decided still what should be the color of the walls. She did not decide still what kind of flooring she wants. she did not decide still what kind of interior design she wants and the different appliances that she wants. Okay, so she has not decided on all these things, but she wants to start off with the construction of her house, right? So what her engineer will do, her engineer will start constructing the house based on the requirements she has given. Then later when she will be giving the remaining requirements, he will implement them. Okay, means here he's not collecting all the requirements at once. He's collecting the requirements in part, he will implement them, and then again he will take a next set of requirements from her because she is unclear with the requirements in the beginning. Okay, so what is happening here? We are doing the risk analysis. In this risk analysis, when she says, okay, see, I want this kind of floor, then the engineer cannot implement it right away because some part of how her house is already done. Now, whenever we are trying to implement something new there, he should take care it will not affect the existing structure. Okay. Now he tries to, do something, a new requirement he is trying to implement, but it should not affect the existing system. He should not spoil what is already there, right? So he is going to take care of it. That is nothing but the risk analysis. Check whether the new requirements are going to affect the existing system. If so, what is the solution for it, right? What is the additional cost to be paid for it? What is the additional duration to be given for it? This is a part of risk analysis. Okay. If we implement the new requirements, what is the risk involved? We got to calculate that in terms of cost, in terms of duration, in terms of how it is going to affect. Okay. This is nothing but the risk analysis. So that is the reason it is used in the riskier projects. What are riskier projects? Let's say you are developing a fire alarm system for some industry. Let's say a chemical industry. If something goes wrong, it can affect the lives of the people. Okay. Let's say we are developing some software for a spacecraft. What happens if something goes wrong here? Our millions and billions of dollars are gone. Okay. And it might affect the environment of our earth. Correct? So when we are developing such critical and riskier projects, we go for such a model, which is the spiral model. Okay, wherein we are going to first evaluate the risk for the new requirements to be implemented, and then only we implement it. And here the drawback means getting the new requirements in the mid of project. This is not there. Even we can accept the new requirements in the mid of project, because this cycle, it is going to continue. Any number of spirals. We start from whatever requirements we have. We do the planning, risk analysis, and we implement, evaluate it. Again, take a new set of requirements, do the planning, risk analysis, implement, and evaluate. Again, take a new set of requirements, follow the same spiral. Okay. So since, it is going on in the spiral, even if the requirements are coming in the middle of the project, they can be accepted. Okay. Fine. Now, with the, new requirements and so many spirals, what is happening to your cost? Cost is also increasing with the every spiral. Okay, cost assessment has to be done, right? Okay. No, Phoebe, actually, this cannot be explained with the AT&T, because in a particular software development, I can see the end application, but how they are following it in their project, we do not know, or which model they are following, that also it's not possible for us to guess. Only during the development, and people who are in the development process, only they know what kind of model they are following. If you look at the end application here, okay, I cannot make out what kind of, model they have used, right? Just looking at this website, we cannot tell which model they have used because the usage of the model is done during the development. Now I don't know whether they followed the waterfall model or whether they went for a spiral model or something else. Okay. Okay, Fabi? Yeah. Alright. So this is your spiral model. You can just understand that it is developed in the spirals and risk analysis is an important thing here. There is one problem here. Okay. This risk analysis process, it is very expensive because any person with less number of experience cannot do this kind of risk analysis. Let's say you go to an inexperienced doctor. The way he predicts is different. You go to an experienced doctor, the way he, thinks of the risk and then he predicts and he treats is different. Why? Because he has a lot of experience there. But when you go to the, experienced doctor, definitely you got to pay more. Correct? So here also, when we are considering such a kind of risk analysis, wherein we got to predict what could happen due to this, what could be the, consequences of this, we need experienced people, expertise. Okay. And when we have to buy such an experience and expertise, definitely we got to pay more. Okay. So the risk analysis is going to be expensive here. And that is why it is not suitable for a small project or a lower budget project. Okay. Next model is agile model. Okay. So before we go to the agile model, I want you to list down all the three models and the features that you have understood, one drawback for each. Okay. All right. So just take 2 minutes for it and write it very quickly. What are the models that you have already learned? List one or two features, whatever you have grasped, and write one drawback. Okay? Fine. Take 2 minutes for it.